My dear students, welcome to today's session. We will take another problem on slope deflection method. I have written that problem on the board here. It is a two-span continuous beam, but there is an overhanging portion. So the span AB is 6 meters, span BC is 4 meters. There is an overhanging portion of 2 meters. The loads are as shown: 40 kN per meter for the entire AB span, 160 kN at the center of BC, and there is overhanging load of 80 kN at a distance of 2 meters from C. But you should note here that moment of inertia for AB is 2I and moment of inertia for BC is I. So to begin with, our primary unknowns are theta A is 0 because it is fixed, theta B is not 0 and theta C is not 0. So primary unknowns are theta B and theta C. Now after this, let us write down fixed and moments using standard formula. MFAB. The standard formula is WL square by 12. It is anti-clockwise, so it is positive. MFAB plus 40 into L square 6 square divided by 12. MFBA minus WL square upon 12. 40 into 6 square divided by 12. MFBC, you can do the calculations. MFBC, the load is acting at the center, so the formula is plus WL by 8, plus W is 160, L is 4, WL by 8. MFCB is equal to minus WL by 8. So the values you can calculate, I have already calculated. I will write down the values. MFAB is equal to 120 kilonewton meter. MFBC is minus 120 kilonewton meter. MFBC is equal to 80 kilonewton meter, which I can see here. 160 into 4 by 8 is 80 kilonewton meter, and this is minus 80 kilonewton meter. So we have written the fixed and moments. After writing the fixed and moments, our next step is we should write the slope deflection equations. How many slope deflection equations? 2 for AB and 2 for BC. So I will do that first. MAB, we can directly write down MAB. I can write the formula for once, and afterwards directly we can substitute. MAB is equal to MFAB plus 2EI upon L of AB into bracket minus 2 theta A minus theta. So let me do the substitution here. MAB, you have found out the value of MFAB. MFAB is 120 plus 2E. What is I for AB? 2I. This is very important. 2I divided by L of AB 6 minus 2 theta A 0 because theta A is 0 fixed minus theta. So if you do the calculation, you are going to get this 120. 2 into 2 4. 4 by 6 is 0.667. So minus 0.667 pi theta. So this is the first equation. Similarly, I will write down MBA. What is the formula? MBA is MFA plus 2EI upon L minus 2 theta B minus theta. That is reverse. So MBA is equal to MFBA minus 120 plus 2E. I is 2I. L is 6 minus 2 theta B minus theta is 0. So it becomes minus 120. 2 into 2, 4 by 6 is 0.66 into 2, 1.33. So minus 1.333 EI theta. So this is the equation 2. Now similarly, let us write down MBC. What is MBC? MBC is MFBC for this BC. MFBC plus 2EI upon L minus 2 theta B minus theta C. So MFBC we have already found out 80 plus 2E. I is I. For BC, I is I upon L. L for BC is 4. 2 is 1 minus ei theta b minus 0.5, this becomes 0.5 ei theta c. So this is my third equation. And the last equation, MCD, MFCD minus 80 plus 2e, r is I, L is 4, reverse now, minus 2 theta c minus theta b. So it becomes minus 80 minus ei theta c, because it is 2 into 2, 4 by 4 is 1, so minus ei theta c minus 0.5 ei theta b. So this is the fourth equation. So 4 equations we have written again. I will explain briefly. You can see this is the beam that is given to you. You have to analyze using slope-deflection method. So the fixed end moments, the primary unknowns are of course theta b and theta c. First we have written fixed end moments, and after that we have written 4 slope-deflection equations. How we have written 4 slope-deflection equations? Using this general formula. Correct? Okay. Now having done this, if you look at all these 4 equations, you will understand that there are 2 unknowns. What are those 2 unknowns? We have seen in the last problem also. The 2 unknowns are, one is ei theta b and another is ei theta c. That means 2 unknowns we have, and we need to get 2 simultaneous equations to solve these 2 unknowns. So that is why now I am going to write what we call the joint equilibrium conditions. So I will write now the joint equilibrium conditions. Note down here. So my next step is joint equilibrium conditions. Same procedure what we had seen in the last session. How many joints we have? We have actually 3 joints, but this joint will not give us anything because it is fixed joint. So we have equilibrium condition at B and equilibrium condition at C to utilize. So first is equilibrium condition at B. We know already moment at B, that is MBA plus MBC equal to 0. So first equation is MBA plus MBC equal to 0. So this is my first Roman condition 1. The second condition, MCB. MCB in the previous case it was 0 because it was a roller and without overhanging. But now there is overhanging portion. Because of overhanging portion and because the load acting in the overhanging portion, there will be moment at C. So MCB is not 0. It is equal to, so you can see, if you call this as B, MCD is equal to 18 to 2, 160. And it is hogging. Hogging here is anti-clockwise. If it is anti-clockwise, it has to be clockwise. So MCB is clockwise. The value should be equal to 18 to 2. It is minus, which is equal to minus 160. So this is MCB equal to minus 160. You must write the reasons in the bracket if you want. Negative. Why it is negative? Because clockwise. We know our sign convention clockwise. Why it is clockwise? Clockwise. Why it is clockwise? Because it is hogging. And for BC, C is the right hand. For right hand, clockwise is hogging. For BC, the right hand is C, so clockwise. The hogging should be clockwise. So clockwise because hogging. So this is how the 2 conditions are equal. This is very important. In the previous example, MCB was 0, but now MCB is not 0. It is 18 to 2, and here it is anti-clockwise, but here it is clockwise. We want moment MCB, we don't want moment MCD. So MCB is minus 160. This is the catch. That is the only difference that is existing between this problem and the previous problem that we have done. Now what you need to do? You formulate this equation, and then you formulate these equations and solve them. Once you solve them, you are going to get, you can see there is one equation, Roman. You can see MBA. You know already MBA, it is minus 120 minus 1.33 ei theta b, MBA. And MBC plus 80 minus ei theta b minus 0.5 ei theta c. That is MBA plus MBC equal to 0. Simplify this. And then the second equation, MCB is equal to minus 160. We know already what is the MCB. Minus 80 minus ei theta c minus 0.5 ei theta b. This you equate it to 160 minus 160. So solve these two equations and what you are going to get is ei theta b and ei theta c. I have already done that, so I will write it here. So the calculations what I have done, I will write ei theta b is equal to, you can check your answers, ei theta b is equal to minus 38.406 and ei theta c will be equal to 99.20. So minus is anti-clockwise. Why? Because the sign convention for rotations is clockwise positive, but the sign convention for moments is anti-clockwise positive. So this is clockwise. This is anti-clockwise, this is clockwise. So having obtained this ei theta b and ei theta c, what you need to do is you have to go to these equations 1, 2, 3, 4. Second equation is here, one equation is not seen, it is already erased. Second, third and fourth equation. Substitute the values of ei theta b and ei theta c and get all the moments. What are the moments? MAB, MBA, MBC and MC. So if you substitute, you are going to get the values of these moments. I have already counted out these moments. So you can do the calculations and verify your answers using a calculator. So I am going to write, so all of you note down MAB. Don't only look at this video, you need to solve this and enter the values in your notebook. That is more important. MAB 145.61 kilometer meter. MBA, all are in kilometer meter only. MBA is equal to minus 68.8 kilometer meters. MBC equal to plus 68.8 kilometer meter. And MCD is equal to minus 160, because already you have substituted minus 160, you must get minus 160 kilometer meter. So having obtained these values, what we have to do is we have to draw bending moment diagram and shear force diagram. I want you to try this. Try drawing bending moment diagram and shear force diagram. In the next session, what I will do is I will show you how to draw bending moment diagram and shear force diagram. Of course, there is no difference in the method that we had from that we had seen in the first session. It's the same, there is no change. So BMD and SFD are very important because their answer should end with BMD and SFD only. I hope you have understood this basic concept of solving this problem with overhanging region. So what is the difference? The difference is MCD is not equal to C. That's the only catch. So let us come to the next session with BMD and SFD, and I want you to also try get the values of BMD, the figures of BMD and SFD. So I will pause here and we will meet in the next session. Thank you.